Hello my dear students, welcome to the JEE PYQ discussion session from the chapter Laws of Motion part 2. Here comes the first question. Consider a block kept on an inclined plane inclined at 45 degree as shown in the figure. If the force required to just push it up the incline is 2 times the force required to prevent it from sliding down, then the coefficient of friction between the block and the inclined plane mu is equal to option A 0.33, option B 0.60, option 3 0.25 and option 4, you got option 4 here, that is 0.5. Okay, yes. So the important part over here is, have a look, the force required to just push it up is 2 times the force required to just prevent it from sliding down. That is the most important part here. Okay, so treating that, let this be the inclined plane and here this is the mass. Now once this body is about to slide down, the forces acting are mg sin theta, that is in the downward direction, and friction will be in the upward direction. So if I treat F1 as the force which is required to keep this body from sliding down, then F need to be what? Mg sin theta minus of F. So I can mark F1 as mg sin theta minus of F. Okay. Now for the same body, if you want to pull it in the upward direction, in that case F2 is the force acting in the upward direction and the downward forces acting are going to be what? Mg sin theta, and in addition to that friction also will be there. So while trying to pull the body in the upward direction, F2, that's going to be what? F2 is going to be F plus small letter f plus mg sin theta. Alright. Now as per the question, for the force required to push the incline up, isn't it? That is the force required to push the incline up, that is F2, that is equal to 2 times F1. This relation is already given as per the question, isn't it? Cross check that. This just to push it up the incline 2 times the force required to just prevent it from sliding down. Okay, fine. So F2 is 2 times F1 that we have. Now let's substitute the values here. What is F2? F2 is marked as small letter f plus mg sin theta. That's equal to 2 into what is F1? F1 is mg sin theta minus of f. Alright. Of course, you know that mu term is supposed to be related with what? Small letter f only. So rearranging that, f plus mg sin theta, that is equal to 2 times mg sin theta minus of 2 times f. I am taking this towards the left. So 3 times f, that's equal to what? 2 mg sin theta, this will go to towards the right, that's going to be mg sin theta only. Okay, once I take this towards the right, next page, that is 3f equal to mg sin theta, 3 times f, that's equal to what? Mg sin theta, mg sin of theta. What is f here? 3 into f is mu mg cos of theta, that equal to mg sin theta. Mg and mg will cancel. And here have a look, what is theta? Theta is 45 degree. So here cos 45 and sin 45, that also will cancel. Now from here I can say that mu is equal to what? 1 by 3, that is supposed to be 0.33, which means option A must be correct answer for this. Is that okay? Now let's move to the next. Question number 2. The time taken by an object to slide down 45-degree rough inclined plane is n times as that it take to slide down a perfectly smooth 45-degree inclined plane. So the time taken to slide down is t1 and that's equal to what? N times t2. That's what given in the question. Now, if I consider a rough surface first, the body starting from here and reaching here. Okay, so it reaches here. What is the distance traveled? Distance traveled is s. So I can go for the relation s is equal to ut plus half of a t square. Here the body is starting from state of rest. That means u is equal to what? 0. Body starting from rest, that means u is equal to 0. Then I can say that 2 times s upon a under root, that is t. This is the time taken. Now, for the rough surface, I repeat, for rough surface, a is going to be what? G sine theta minus of mu g cos theta for rough surface. And for smooth surface, a is going to be what? Simply g sine theta only. Here this is for smooth surface. And here this was for rough surface. So, if I go for the expression for rough surface, T1, that's going to be what? Root of 2 times S upon G sine theta minus of mu G cos of theta. And for the smooth surface, it is T2. So, as per the relation, it is N into under root of 2 times S upon what? G sine of theta. Now, while looking forward to the cancellations possible, of course, 2S and 2S will cancel. G and G will cancel. Since it is 45-degree, sin theta and cos theta will cancel. So, what I am left with here is 1 upon root of 1 minus mu, that is equal to, on the right hand side I am left with just n only. Let me square this term. Okay, while squaring, on left hand side I will be having 1 upon 1 minus mu, that is equal to, on right hand side I will be having what? N square. Okay, so here this is 1 upon n square equals 1 minus of mu, or I can say mu is equal to 1 minus of 1 by n square, which means option 4 must be the correct answer here. Now let's move to the next, that is question number 3. Question 3 says, a train is moving with a speed of 12 meter per second on rail which are 1.5 meter apart. To negotiate a curve of radius 400 meter, the height by which the outer rail should be raised with respect to the inner rail is. So, here this is rail track 1 and here this is track 2. Alright. Now, we need to raise the outer rail through a height h. Now, this is going to be the new inclination. Okay. So, in this new inclination, if I consider the forces acting on the train, capital N is going to be the normal reaction and M into G, it's going to be the weight. And here this is the horizontal and theta is the angle through which this particular rail got lifted. Okay. Now, considering the equilibrium condition along y axis, I can say that if this angle is theta, so here this is what? N cos of theta, and definitely this angle is going to be theta only. And here this is what? N sin theta. Okay. Now, the necessary centripetal force which is required to keep this train moving in that circular turn, that is going to be offered by what? N sin theta only. So considering that, I can say that the necessary centripetal force, that is mv square by r, that is going to be offered by n sine of theta. If we consider the equilibrium along y-axis, I can say that n cos theta is equal to mg. Then what is n? N is mg by cos theta. So m into v square by r, that is now equal to, what is n? N is mg by cos theta. Mg by cos of theta into sin theta. Okay. So here m and m will cancel each other. Sin theta by cos theta is tan theta. So v square upon capital R, that is equal to g into tan of theta. Okay. Now here, what could be tan theta? Tan theta need to be h upon this particular distance, and that is 1.5 as per the question. So tan theta can be written as what? H by 1.5. So v square upon capital R, that is now equal to g, we can take it as 10. Okay, and tan theta is what? H by 1.5, that is 3 by 2. Okay, g tan theta. What is v square? V square is 12 square. So 12 into 12 upon, what is capital R? 400. Okay, that is now equal to 10 into h into 2 by 3. Fine. So here, if I try for further cancellations, so of course this is going to be what? This will cancel each other, this will leave what? 6 here. Okay. Now again trying for further cancellation, here this will go, it's going to be 5, and here this is going to be what? 6 again. Okay. Now small letter h, that is now going to be, let's check the possibilities here. So here this is going to be 6 into 3 all divided by 5 into 4 into 10 to the power minus of 2. 10 to the power minus 2. Okay. Now again trying further cancellations. Here this one and this one will go. That's going to be 2 here. Sorry, 3 there, and it's going to be 2. Alright. Now here this is what? 3 3s are 9, and 9 into 6 is 54. So here this is 54 divided by 10 into 10 to the power minus of 2. Basically that should be 5.4 centimeter. Okay, that means option 2 must be correct answer in this case. Was that okay? Now let's move to the next, that is question number 4. Question number 4 says, a bullet is fired into a fixed target, loses 2/3 of its velocity after traveling 4 centimeter. It penetrates further, capital D into 10 to the power minus 3 meter before coming to rest. Then the value of capital D is. See, here this is the block. Here this is the block. And this is the bullet which is entering, that is entering with the speed of v meter per second. Now after traveling through a distance of say 4 centimeter as per the question, it's losing 2/3 of its velocity. That means it is left with v by 3. Now after traveling through some more distance, it is coming to state of rest, and that distance is marked as capital D into 10 to the power minus of 3 meters. So we need the value of capital D, and this value is what? 4 into 10 to the power minus 2, 4 centimeter. Okay. So let me take this point as A, let me take this as B, and let me take the point where it comes to state of rest as C. Now I am going to consider the journey from A to B first. I am going to consider the journey from A to B. Their final velocity is v by 3. So if I consider the equation v square equal to u square plus 2as, final velocity is v by 3, the all square, that is equal to v square minus of 2 times a into distance traveled is 4 into 10 to the power minus of 2. Okay. So here this is going to be what? V square by 9, that equal to V square minus of, here this is 4 2s are 8 into A into 10 to the power minus of 2. If I rearrange this, here V square is common, here this is going to be 1 by 9 minus of 1. Okay, that is equal to minus of 8 A into 10 to the power minus of 2. 1 by 9 minus of 1, that is what? Minus of 8 by 9. So rearranging this, I have minus of 8 V square by 9, that is equal to minus of 8 A into 10 to the power minus of 2. This minus and minus will cancel, 8 and 8 will cancel. V square is what? V square is 9 times A into 10 to the power minus of 2 now. Now let me consider the journey from B to C. There the final velocity is 0. So 0 equals V by 3 the all square minus of 2 into A into capital D into 10 to the power minus of 3. Here it is 0, that is equal to, here this is 1 upon 9 into V square. V square is 9A into 10 to the power minus of 2 minus 2 into A into capital D into 10 to the power minus of 3. Alright. Now this one and this one will cancel. Small letter A is also common, that will get cancelled each other. Now if I take this towards the left, I can say 2 into capital D into 10 to the power minus of 3, that is equal to 10 to the power minus of 2. This one and this one will cancel, it will leave only 10 to the power minus 1, and here this is going to be 1. This will go to the right. Now capital D is equal to what? 10 by 2, which means it should be 5. That means option B must be correct answer in this case. Was that okay? Now let's move to question number 5. The question says, all surfaces shown in figure are assumed to be frictionless and the pulleys and the strings are light. The acceleration of the block of mass 2 kg is. That means basically we need to find out the acceleration of this. Okay. So here if I take T as the tension, so here also it's going to be T and here also it's going to be what? T, and here this is going to be what? 2 times T. Okay, which means 2 times acceleration of 4 kg mass, 2 times acceleration of 4 kg mass is going to be equal to what? Acceleration of 2 kg mass. I am telling about the magnitude part only. I repeat, I am telling about the magnitude part only. Direction is opposite. If this is going up, this will be coming down. Okay, yes. So keep that in mind. And we need the acceleration of what? 2 kg mass. So we need the acceleration of this or in the upward direction, whatsoever it may. We need that. Yes. Now, let's consider the motion of this one first. So here 4 kg mass is going to come down with an acceleration of say a suffix 4. I am marking it as a suffix 4. So 4 times 4 means it is the mass of the body into acceleration of that 4 kg mass. I am marking it as A4. That is equal to the weight of the body. Acceleration due to gravity, I am going to take it as G only. So weight of the body is 4 times G into minus of 2 times T upward. 4 times G, that is the downward force, minus of 2T is the upward force. And if I consider the motion of this, 2 into acceleration of 2 kg mass, the upward direction, that is equal to T in the upward direction minus 2 into G into sine theta, that is sine 30, that is 1 by 2. 1 by 2. So this one and this one will cancel each other. Okay. Now we have got a relation over here. What it is? Relation is 2 times A4, that is equal to what? A2. Okay. So we need the value of what? A2. So I am going to replace A4. Okay, A4 can be replaced as A2 by 2. So here 4 into, okay, A4 we are replacing it as what? A2 by 2. So A of 2 by 2, that is now equal to 4 times G minus of 2T. What I have here? 2 times A2. Okay, now here this one will cancel each other with 2A2 only. That is now equal to, here it is capital T minus of small letter g. Okay, so if I add these two, and if I can have 2 here, then T and T will cancel each other. So I am considering that possibility first. So I will be multiplying this term with 2, and it will be also multiplied with 2, and this also will be multiplied by 2. Now here this is 2 2s are 4, and 4 plus 2 it is 6. So 682 on the left hand side, 2 2s are 4 plus 2 it is 682. That is now equal to plus 2 and minus 2 will cancel each other. Here this is 2g, 4g minus of 2g, that is 2g. This one and this one will cancel each other, will leave 3 on the left. Now A2 from here, I can say that A2 is equal to what? G by 3. Okay, which means option C must be correct answer in this case. Now let's move to question number 6. Question says, in the given arrangement of a doubly inclined plane, two blocks of masses capital M and small letter m are placed. The blocks are connected by light strings passing over an ideal pulley as shown. The coefficient of friction between the surface of the plane and the block is 0.25. The value of small letter m, for which mass capital M, which is equal to 10 kg, will move down down with an acceleration of 2 meter per second square is. So here this acceleration is 2. So 2 meter per second square is the downward acceleration. Now let's consider the free body diagram first. So here this is the plane for the bigger mass, and here this is for the smaller one. So here this is small letter m, here this is capital M. Let this be the pulley, be the support, and let's connect it this. This is the coming down with an acceleration of 2 meter per second square. So definitely this also will be moving up with an acceleration of 2 meter per second square. So here tension is T and here also tension is T. If I consider the combined movement, capital T is an internal force, it will cancel each other. So here I have got inclinations are about 53 and 37, isn't it? 53 and 37. So here this is capital M into G into sine of 53 in the downward direction, and here this is what? Mg into sine of 37. So here you are going to have friction in the opposite direction, and here you are going to have friction in the opposite direction, but in the upward direction for the plane, and here it is down the plane, friction is. So if I consider the combined motion, I can say capital M plus small letter m into 2, that is the acceleration. That means I am considering the motion like this. Okay, here this is coming down and here this is going up. So there the favoring force, that means the one that favors the motion, that is capital Mg sine of 53. That is the force that favors the motion, and what opposes the motion is F here, F here. So I would like to mark this as F1 and I would like to mark this as F2. F1, F2 and Mg sine 37. All these three forces are opposing. So minus of F1 plus F2 plus Mg sine of 37. We need the value of small letter m. Okay. Now here this is 2 times capital M plus 2 times small letter m, that is equal to Mg into sine of 53. Okay, let's do one thing. Let's substitute the values here. What is capital M? capital M was 10 and G was also 10 and sine of 53. Okay. So try to understand this case. Here this is 3, 4, 5 and here this is 53 and here this is 37 and here this is 90 degree. Now sine of 53. Sine of 53 is supposed to be 4 by 5. Okay. I am going to substitute that here. 4 by 5 minus of what is mu here? Mu is marked as 0.25. Okay. So I am going to mark it as 1 by 4. So this negative will go in and all the values are going to be negative. So minus of 1 by 4, that is mu, into F1. F1 is this. So the friction on this one is mu mg cos of theta. What is m? M is 10. G is again 10. And cos theta here. Cos theta is what? Theta is 53. So cos of theta is going to be what? Cos of theta is going to be 3 by 5. So 3 by 5 here minus of F2. What about F2? F2 is the friction offered by this. There also it's going to be what? 1 by 4, writing it here, minus of 1 by 4 into mass, what? Mass is M, that we need to find out, into G, that is 10, alright, into cos of 37. Cos of 37 is going to be what? Cos of 37 is supposed to be 4 by 5. Okay, 37. So base by hypotenuse, it's supposed to be 4 by 5. Alright, minus of mg sin 37. Mg sin 37 is going to be what? I can mark it as minus of, taking this minus here, m into g, that is 10, into sine of 37. Sine of 37 is 3 by 5. 3 by 5. So this is that the substitution of the forces on the right. Okay, now let's try to check out the possibilities of cancellation here. So this one and this one will cancel each other, will leave 2 here. Okay, and here I try the next part, that's going to be, this one and this one will cancel each other, will leave 5 there on the top and 2 on the bottom. Again this one and this one will cancel each other, will leave 5. So then this one and this will cancel. So there's going to be 15 left. Okay. Now if I consider the cancellations here, it's going to cancel each other, will leave 2 here. And here if I consider here, this will cancel each other, will leave 2. So now what is left? I have got 2 times capital M plus 2 times small letter m, that is now equal to, here this is 4 2s are 8 and here this is 80. And here this is, here we have got 5 and 5 3s are 15. So minus of 15. Okay. And here I have got what? 2m, minus of 2m. And here I have got what? Minus of 6m, minus of 6 times m. Okay. Now, if I consider this, what it is? Capital M was 10. So here this is going to be 20. Now here this is 2, here this is 6, this will come to the left, that's going to be 10 times m. Because it's 8 coming to the left, that's going to be 10 times m. And what I have here is 20, this will be going towards the right. So it's going to be 80 minus 20 minus of 15. 80 minus 20 is 60, 60 minus 15 is 45. So 10 times m, that's equal to what? 45. I repeat, 10 times m is 45. So from here I can say that m is equal to what? 4.5. M is equal to what? 4.5. That means option 2 is going to be the correct answer here. Alright. Next is question number 7. The question says, a block of mass 5 kg is placed on a rough inclined surface as shown in the figure. If capital F1 is the force required to just move the block up, the incline, and F2 is the force required to prevent the block from sliding down the incline, then the value of F1 minus F2 is. So F1 is the force that is required to just move the block in the upward direction, isn't it? Fine. So once we are trying to move the block in the upward direction, the force what we need, F1, that is mg sine theta plus mu mg cos of theta. And once we want to prevent it from sliding down, then the force what we require, F2, is mg sine theta minus of mu mg cos of theta. We need F1 minus F2. So F1 minus F2 is F1 minus F2, that is supposed to be what? 2 times mu mg cos of theta. Alright. We are provided the value of mu, yes. So here this is going to be 2 into mu is 1 by 10. Okay. M is what? 5. Alright. And acceleration due to gravity is what? Acceleration due to gravity is need to be 10. And cos of theta, that is root 3 by 2. Root of 3 by 2. So 10 and 10 will cancel, isn't it? 2 and 2 will cancel. We are left with 5 root 3, which means option 2 must be the correct answer in this case. Alright. Now let's move to the next, that is question number 8. A wooden block of mass 5 kg rests on soft horizontal floor. When an iron cylinder of mass 25 kg is placed on the top of the block, the floor yields and the block and the cylinder together go down with an acceleration of 0.1 meter per second square. Then the action of force on the system on the floor is equal to, see, imagine there is no support. In that condition, 5 plus 25, that is 30. It is supposed to come down with an acceleration A. That is supposed to be with the influence of its own weight, and that is going to be 30 into what? 9.8. Of course, this one and this one will cancel each other. A need to be what? 9.8. Isn't it? Now, acceleration is not that. That means some force is opposing the motion. So, how to find out that? Again, mass is 30 into acceleration is A, which is given as 1 by 10. That is equal to weight of the body. Weight of the body is supposed to be 30 into 9.8 minus of n. Isn't it? This one and this one will cancel each other. We'll leave only 3 on the left. Now, that is going to be, if I consider this, that is 98 into 3. So, here this is 8 3s are 24. I am left with 2 here. 9 3s are 27. 27 plus 2 is 29. It's 294. So, 3 is equal to 294 minus of n. So, definitely capital N is supposed to be what? 294 minus of 3, that is 291. Option 3 must be correct answer in this case. And here comes the last question. The question says, a circular table is rotating with an angular velocity of omega radian per second about its axis as shown in the figure. There is a smooth groove along the radial direction on the table. Steel ball is generally placed at a distance of 1 meter on the groove. All the surfaces are smooth. That is very important. All the surfaces are very smooth. If the radius of the table is 3 meter, then the radial velocity of the ball with respect to the table at the time when ball leaves the table is x root of 2 omega meter per second. Then the value of x is. Here the important part is you must know how the body is getting its speed increased. It was left at u equal to 0 with respect to the groove, with respect to the disc, at x equal to 1, and the radius is what? 3 meters and x is 1 meter and here it is 3 meter. So if we observe from here, from the group, this body is moving in the outward direction and this particular force is offered by the centrifugal force. And what is that centrifugal force? It is supposed to be r omega square, general expression. It is supposed to be what? R omega square. And sorry, this is not the centripetal force, this is centrifugal acceleration. So centrifugal acceleration is what? R omega square. At any point x, I would like to say the centrifugal acceleration is x times omega square. And we all know that A, that is equal to what? V into dV by dx. And that is equal to what? X into omega square. If I rearrange this, V into dV, that is equal to x into dx into omega square. Now, if I integrate this term, initially it was at 0 and let me assume that it is once it was leaving, the speed is what? V0. So, 0 to V0, V dV, that is equal to integral of, at the time it started the motion, it was at x equal to 1 and while leaving it is x is equal to 3, x ds times omega square. So, while integrating, I am going to have v square by 2 here and x square by 2 there. So, 2 and 2 will cancel each other. Here this is going to be v square between the limit what? 0 to v naught. So, substituting the limit, I can mark it as v naught square, that is equal to, here substituting the limit, it is going to be 3 square minus of 1. 3 square is 9, minus of 1 it is 8. So, 8 into, what is left here? Omega square. Now, I can write this as what? 4 into 2 times omega square. Now, what is V naught? V naught is supposed to be 2 root 2 into omega square. And as per the question, it was x root 2. X root 2 omega square. So, while comparing, x is equal to 2. Alright. So, that was all from my end for this session. We will meet soon with another chapter's PYQ discussion. Till then, bye bye and take care.